Hi. So now we're going to talk about the analysis of ethanol in alcoholic beverages using gas chromatography.
Assalamualaikum. My name is Batrisyia Iman Binti Mohamad Taha 2017828528. I will start by explaining the introduction part of the analysis of ethanol concentration in alcohol samples. Gas chromatography is a method used for separation and detection of a chemical composition of a sample mixture. This method was used to evaluate the concentration of ethanol in alcoholic drinks, where beer, wine, and whiskey are the focus throughout this analysis. Gas chromatography has been used as it is reliable and sensitive for volatile samples. Because this analysis discusses on retention time, it is based on a qualitative analysis. A qualitative analysis involves identification of a component by means of peak data on the chromatogram. Since retention time is a specific property of a component, it is then used to identify the component. The specific type of detector used is flame ionization detector (FID). Injected into the instrument, sample then reaches gas stream, then deliver the sample into the column. The carrier gas must be dry and chemically inert like helium and also nitrogen. Total of elements approach the column is analyzed by the detector. Ethanol, C2H5OH, are colorless, a flammable chemical compound that is best known for its use in alcoholic beverages. The steps in the ethanol production process include a chemical reaction called fermentation. It takes place in which the glucose is broken down to ethanol by the action of enzyme in the yeast.
I am Alya Sabrina Binti Rusmi, and I will be presenting the methods of determination of ethanol content in alcoholic beverages by using gas chromatography.
Firstly, the part A, which is the preparation of standard solution. Number 1, 10 gram of ethanol was dispersed into a 1000 ml volumetric flask. Number 2, the distilled water was added to the flask until it reached the mark. Number 3, the percentage weight over volume of standard solution ethanol were recorded. Next is part B, which is the Trace GC operating system. Number 1, Trace GC 2000 was equipped with computer integrated software and FID detector. The flow rate of hydrogen gas and oxygen were both set to 300 ml per minute. The temperature of FID detector and injection was set to be 285 degrees Celsius and 225 degrees Celsius respectively. Number 4, helium and nitrogen acted as carrier gas. Both of their flow rate was set to be 2 ml per minute. The CP Wax 58 CB separation column was used. The column temperature for wine and beer was set to be 40 degrees Celsius, while for whiskey, it was set to be 45 degrees Celsius to 245 degrees Celsius. And lastly, the speedless injection mode was selected with limitation to 0.1 microliter for whiskey solution. For beer and wine, the split injection mode was used. Next is the part C, which is the determination of alcohol content in alcoholic beverages. Number 1, standard solution ethanol was injected into the GC by using a syringe. The peak for ethanol was determined and recorded. Number 3, 5 ml of 1% standard solution was added into 0.5 ml of wine solution. The solution was swirled gently. 0.1 microliter of the mixture solution was injected into the GC by using syringe and the ethanol content was recorded. Each analysis was repeated for 3 times to get accurate reading. Step 3 until 6 was repeated by using beer and whiskey solution.
Hi, Assalamualaikum. So my name is Saiyidah Nafeeha binti Helmi with ID number 2018-244664. So now I will be discussing about the results and discussion of this experiment. Figure 1 shows the chromatogram result of standard solution, ethanol solution. The retention time of ethanol peak is at 2.038 minutes. Figure 2 shows the chromatogram results of beer. The average percentage of alcohol content in these beer drinks tested was 12.5%. The retention time of the peaks at 2.2 minutes. Next is wine. Figure 3 shows the chromatogram results of wine spectra on chromatogram. The average percentage of alcohol content in this drink is 16.0%. Retention time of ethanol peak on this chromatogram is at 2.3 minutes. Last but not least is our last sample, which is whiskey. Figure 4 shows the chromatogram results of whiskey drink. The average percentage of alcohol content in all the whiskey drink tested is 40.0%. Retention time of ethanol peaks in the chromatogram labeled as 1 in the figure 4 is at 2.73 minutes. Table above shows the result for samples, its retention time, and the average percentage of alcohol content.
Hi, and Assalamualaikum. My name is Khairunnisa Binti Norazha, and I will be explaining on the discussion. So let's get started. So for discussion, there are 3 beverages used, which are wine, beer, and whiskey. Gas chromatography is a good choice of method for analyzing alcohols, as it focuses on analyzing volatile compounds. It is known that alcohols are volatile compounds. The detectors used is flame ionization detector, or FID, as it is good in detecting hydrocarbons. The stationary phase used in this experiment is capillary column, while the mobile phase is the carrier gas, which are nitrogen and helium. It is known that helium provides good efficiency and analysis time, but nitrogen is the best in providing good efficiency in gas chromatography.
Firstly, in this experiment, to get the retention time of ethanol, FID was used and set at 240 degrees C by using Zebron ZB-BAC1 as the stationary phase. The column temperature is set at 40 degrees C. Mobile phase used for this solution is helium gas with the flow rate of 2.57 ml per minute. Ethanol use is in the lowest concentration because this ethanol solution are used as the standard solution. Sample was injected by using a split mode, and after the analysis was done, the retention time shown peak at the chromatogram is at 2.038 minutes.
For wine, the detector used is FID2 with the temperature of 240 degrees Celsius by using Zebron ZB-BAC1 as a column or stationary phase. The column temperature is 40 degrees C. Thus, this indicates that the column is isothermal run as it uses the same temperature along the whole experiment. The mobile phase used is helium gas with the flow rate of 2.57 ml per minute. The injection mode for this experiment is split mode. Since the average alcohol, the strong alcohol for wine is 16%, the retention time obtained is 2.3 minutes. Next is beer. Beer uses the same settings as wine by using FID and was set up at 240 degrees C with the help of Zebron ZB-BAC1 as a column or stationary phase. The column temperature is 40 degrees C, which means it also uses isothermal run. The carrier gas used was helium with the flow rate of 2.57 milliliter per minute. The average alcohol content for beer is 12.5%, thus indicating the retention time of beer is 2.2 minutes by using split mode when injecting the sample in the injection port. And lastly is whiskey. Whiskey has the most alcohol content with 40%. It uses splitless mode as the injection mode and nitrogen as the carrier gas or mobile phase, with the flow rate of 2 ml per minute. By using the column Polar CP Wax 58 CB as a stationary phase, and the temperature was set up step by step by starting from 45 degrees Celsius to 245 degrees Celsius at 45 degrees Celsius per minute. Thus, this shows that temperature programming was used in this experiment. FID was used as the detector and the temperature was set up at 285 degrees Celsius. Thus, the retention time obtained was 2.73 minutes.
Hi, my name is Amir Rafiq and I'm going to talk about the conclusion. In conclusion, the higher the retention time, the higher the ethanol concentration in alcohol beverages. Therefore, whiskey has the highest concentration of ethanol as it has the highest retention time, followed by wine and lastly beer. The retention time for each and every solution are 2.73 minutes, 2.30 minutes and 2.20 minutes respectively. The advantages of using gas chromatography: it has high efficiency. Due to its high efficiency, GC allows the separation of the component of complex mixture in a reasonable time. Also has high sensitivity, as GC has multiple detectors with high sensitivity, which are flame ionization detector, thermal conductivity detector, and electron capture detector. Next, it has accurate quantitation and it is inexpensive compared to the HPLC. The limitations of using gas chromatography: it is very limited to thermal, stable and volatile compounds, or the result of the gas chromatography is not accurate. Last but not least, the separated component can be used only once. The sample has been destroyed when it goes through the detector, therefore it cannot be analyzed for future research. Thank you.